Now let's talk about the derivative of a function with a natural power by definition. So this will apply for any variable with a natural power. So let's find the derivative with respect to x by definition of x to the power m, where m is any natural number. So obviously we'll let y be equal to x to the power m, where m is any natural number, and this will be equation number 1. So m can be any natural number, so this particular method will apply for any variable with the natural power. So the first step was to take the increment on both sides. So and the y will become y plus delta y, and any where x on the right hand side will become x plus delta x. So x to the power m will become x plus delta x to the power m. And we'll take this y to the right hand side, and so this y will become negative y over here, and so this is equation number 2. And step 2 was to put the value of y from equation number 1, which was this, into equation number 2. So delta y plus delta x to the power m will remain as they are, and this y will become x to the power m as per equation number 1. And over here we will basically multiply this entire thing with x to the power m over x to the power m, because x to the power m over x to the power m will just basically become 1, so it will not affect this equation in any way, but it will make our calculation simpler. So oops, not xm, x to the power m. Okay, so now basically what we'll do here is we'll I guess separate this expression into two different expressions. So this negative sign will be here, and so this will become x plus delta x to the power m over x to the power m minus x to the power m over x to the power m. Now these will be cancelled out and they'll become 1. So it results in 1. And now what you'll do is you'll separate these two terms further into x to the power x plus delta x to the power x. And or you remember, x to the power x becomes this 1. And now you'll apply the binomial expansion on this particular expression. So this is the formula for the binomial expansion as we've discussed earlier. And once you apply this formula on this expression over here, it will become this. Now you remember we had this negative 1 over here, so it will basically cancel out with this 1. So this will become 0, and every expression now will have at least one delta x to the power x expression in them. The first one will have one delta x to the power x expression, the second will have delta x to the power x whole square, the third expression, which comes after this addition sign, will become m into m minus 2 over 3 factorial into delta x to the power x whole to the power 3. So delta x over x will just come in further terms with increasing power. So we can take one delta x to the power x common from all of this expansion, from this series basically, and the expression will eventually become this. Whoops. Okay. So now we move to step 3, which was to divide both sides by delta x. So the left hand side becomes delta y over delta x, and over here you'll multiply. This is the delta x being multiplied. This delta x and this delta x will cancel out. So you're left with this, and so We'll go to step 4, which was to take the limit as delta x approaches 0 on both sides. So now on the left hand side you have the complete expression for the derivative of y with respect to x, and on the right hand side we'll basically replace every delta x expression with 0 because delta x is approaching 0. So basically this delta x over here will become 0, and in all further expressions that are being added up in this series, all of them will have at least one delta x to the power x expression with increasing power, obviously, and so all of those will become 0 as well. So every expression after this m being added up will become 0. So this is what this becomes, and so this m and being added up with an infinite number of zeros. So in the end you'll just have this one m over here, and on the left hand side and on this side this expression will become x to the power m minus 1 because this is being divided by x, so this becomes x to the power m minus 1, and so this is the final expression, and this will be applicable for all variables, the derivative of all variables with a natural power.